Hello, in this short video we are going to investigate the following A-level problem on the topic of constant acceleration in one dimension. In a car race, car A takes t seconds less than car B to reach the finish line and crosses the finish line with a velocity v greater than the velocity of car B at that point. Assuming both cars start from rest and travel with constant accelerations a sub 1 and a sub 2, prove that v equals to t times square root of a1 times a2. Pause the video at this point and give it a try. Okay, so to solve the problem, I write the equation of motion for each one of these cars. So let me write x sub a at time t. I'm using capital T because little t is already reserved in the problem for something else. So let me just use capital T for generic time. This becomes 1 over 2 the acceleration of that car, which is given to be a sub 1 time to the power of 2. But because they have started from rest, I do not have any initial velocity. So that is the formula for the location of car A at the generic time t. And I can write the similar thing for car B. So this becomes 1 over 2 a sub 2 t squared. And for velocities, we can also write velocity of car A at the generic time t is equal to a1 t plus, of course, the initial velocity, which is 0. And for this car, I can also write v of b at t is equal to a sub 2 times t. But now let's say that t naught is the time that it takes for car A to reach to the end. So t naught, the time that car A takes for car A to reach to the end of the course, okay? And now it means that so if the length of the course, let us say, is L, then it means L is equal to x sub A at t naught. But car B reaches to the end t seconds later. So this means that L is equal to xb t seconds later than this. So it is t naught plus t. Okay, so this means that x sub a t naught should be equal to xb t naught plus t. So, because they are equal. So I go back to this equation, I calculate xa at t naught, which becomes simply 1 over 2 a1 t naught squared. This is equal to xb calculated at this instant of time. So I have to replace the capital T with this expression. So this becomes 1 over 2 a sub 2 t naught plus t squared. Okay, so for the time being, let me simplify these and write this expression here to see how should we continue. It's not very clear yet. Okay? But what about velocities? So I know that the velocity of the car A when it reaches at the end is the velocity of A calculated at t naught. Yes? Okay, so v sub A at t naught is equal to, on the one hand, let me use the formula, is a1 t naught. And then if I calculate vb at t naught, this becomes equal to a2 t naught. Sorry, I have to, because the car B reaches at the end t seconds later. Yes, so it becomes a2 t naught plus t. And on the other hand, according to the information in the problem, vb at t naught plus t is v meters per second, or any units given in the problem, is less than this v at t naught. So this becomes a1 T naught minus V. But what is this expression? That expression is this. So this becomes A2 T naught plus T is equal to A1 T naught minus V. Okay, so if I multiply these, it becomes A2 T naught plus A2 little t is equal to A1 T naught minus V. Okay, so this is also another relation that I have. But do you remember, the problem is asking us to prove that V is equal to T square roots of A1, A2. This is what we want to show. So this means that I have to keep V, T, A1, and A2 and get rid of all the other variables. So for example, here T naught should be eliminated because T naught does not play any role here. So how can I eliminate T naught? Very simple. So I will calculate T naught from this expression and put it in the previous expression. Okay? Okay, so let us do that. So in order to calculate T naught, I move this to the left and I factor a T naught out. So this becomes this. And then I move this to the other side, so it becomes minus A2T minus V. So now, what is T naught? So let me write here. So T naught is equal, let me factor a minus sign out, A2T minus plus V divided by A2 minus A1. This is T naught. Okay, let me try to simplify this expression as much as I can. For example, let me move this to the other side. So, is it useful? No, I don't think it's that useful. So let us just plug this there, okay, to see what happens. Because there is nothing we can do much here. So I will write T naught, I will replace T naught with that expression, so it becomes A1. But when I raise this to power 2, the minus sign will be cancelled. So it becomes A2T plus V divided by A2 minus A1. Both of them squared, yes. This is A1 T naught squared equals to A2. And then I have to write T naught plus T. So if you don't mind, let me write T first. T naught is negative. A2T plus V, A2 minus A1 squared. And then, in principle, the problem is solved because the parameters involved in the problem are now just A1, A2, T, and V. And what we want to show is something, a relation among A1, A2, T, and V. So, of course, this is a little bit messy. Apparently, we can simplify it as much as we reach to that very simple and nice expression. So how can I do that? So let me keep this for the time being. So I would write it as A1, A2 minus A1 squared. I don't know exactly, so let me keep it for the time being. But here I can take the common denominator. The denominator to power 2 will go out, so it becomes A squared, A sub 2 minus A sub 1 squared. But this is now multiplied here, so this becomes A2T minus A1T, and this minus sign will go here, so it becomes minus A2T minus V. Okay, and then I have a power of 2 here. Okay, so let me see if I can fit things here. First of all, this denominator and that denominator are gone. This A2T and minus A2T are gone. Okay? So, if you don't mind, the only thing we can do now is to raise this to power 2, multiply, and then do the same thing there and simplify. That's the only thing we can do. Okay? So, I would say I would raise it to power 2, so it becomes A squared to the A sub 2 to the power of 2 T squared. But A1 will be multiplied in, so it becomes A1. It becomes this expression. 2 times the first one times the second one, then multiplied by A1, so it becomes 2A1 A2 VT. And the second one squared multiplied by A1 becomes A1 V squared. On the right hand side, first of all, these negative signs will go away because of this power of 2. I raise it to power 2 and multiply it by A2. So the first one squared multiplied by A2 becomes A2 A1 squared T squared. 2 times the first one times the second one multiplied by that, it becomes 2A1A2 and TV. And then finally, this one squared multiplied by A2. Okay? These are the things we have. But we are lucky because this term and that term from both sides are cancelled. And then what I am left with is just these terms. So if you don't mind, let me now write it here so I do not have enough space. So let me open up some space here. I am left with a1, a2 squared t squared of course, plus a1v squared on the right hand side. I will have a2 a1 squared. So if you don't mind, let me write a1 squared, a2 t squared in order. And then I have a2 v squared. Okay, but I think you see that we are done. Why? Because I move this term to the left. It becomes a1 a2 squared t squared minus a squared a2 t squared. And I keep this on the right. And I move this to the right. So it becomes minus a1 v squared. But here, what I can do, I can factor a1, a2, and t squared out. From here, a2 is left. From here, minus a1 is left. And here, I factor a minus, I factor a v squared out. a2 minus a1 is left. Now, everything is done because a2 minus a1 and a2 minus a1 are gone. So v squared is equal to this expression. If I take square root sign, if I take square root, this becomes v, t squared becomes t, and this expression becomes square root of a1, a2, and that is exactly the expression that we were supposed to reach at. Okay, sorry for that. This is a little bit messy, but I hope that this video was useful for you. You can sit down and do the calculations in more patience so that you can see everything works fine. Thank you very much.